Hello students, welcome to Unacademy. This is your KP sir, Krishna Prakash. In Unacademy, we are going to launch previous year questions solutions. So each year, from each subject, individual videos we are going to release. So that will benefit a lot of students. So we are going to launch in the YouTube channel of Unacademy. Subject wise, year wise, previous year GATE solutions I am going to teach. Okay, now today the topic is GATE 2020 Environmental Engineering solutions. All questions both in set 1 and set 2 environmental engineering solutions we are going to study today. Okay, the first question given in set 1 mark question. An amount of 35.67 milligram of HCl, 35.67 milligram of HCl added to distilled water, and the total solution volume is made to 1 liter. Means that is 35.67 mg per liter of 37.67 mg per liter of HCl, because into 1 liter 35.67 milligrams added, that means 35.67 milligrams per liter of HCl. Atomic weight of hydrogen and chlorine 1 and 35.5 respectively. Neglecting dissociation of water, so you neglect water is dissociation. The pH of solution is required. You need to estimate pH of solution. What is pH? Now you'll consider the chemical reaction. H plus Cl minus gives HCl. How much HCl is present? 35.67. How much hydrogen is present? Because pH is determined. What is formula for pH? Minus log 10 into H plus, negative logarithm of hydrogen ion concentration. That is only pH. So we can write down for pH negative logarithm of minus log 10 into H plus, negative logarithm of hydrogen ion concentration. So first we need hydrogen ion, that too in which units? Mole per liter, in mole per liter. For that you take here atomic weight of hydrogen, which is equal to 1, atomic weight of HCl, which is equal to 36.5. Now what is hydrogen? Simple, na? So we can take just cross multiplication. We'll consider just cross multiplication, will derive H plus ion concentration. H plus is equal to 36.5 is atomic weight of HCl, 1 is atomic weight of hydrogen. Now what is H plus? So what is H plus? We'll take it now. 1 into 35.67 divided by 36.5. Then what is the answer you are getting? 0.97726 mg per liter, milligram per liter. But in pH formula, which unit we need hydrogen? Mole per liter. That is very important. pH formula, hydrogen to be taken always in mole per liter. So we need to convert hydrogen in milligram per liter to mole per liter. H plus in mole per liter is equal to, you can take H plus in milligram per liter divided by atomic weight into 1000. For any chemical you take this formula. X in mole per liter, you remember like this, X in mole per liter is equal to X in milligram per liter by atomic weight into 1000. Atomic weight of X you can take. For any chemical, for conversion of milligram per liter to mole per liter, you write down here. For any chemical, X in mole per liter is equal to X in milligram per liter divided by atomic weight of X into 1000. This is a shortcut formula to convert mole per liter milligram per liter to mole per liter. Now we are converting 0.97726 divided by atomic weight of hydrogen 1 into 1000. So what you are getting answer here? 0.97726 into 10 power minus 3. 10 power minus 3 mole per liter. Mole per liter. Now pH is equal to minus log 10 0.97726 into 10 power minus 3. What is pH value finally? What you are getting pH value finally? Minus log 10 into 0.97726 into 10 power minus 3, which is 3.009. We'll take it 2 decimal value 3.01. This is the answer. So clear the question? According to given options, what is the answer? Option C. 3.01 options are provided according to given options. So answer is option C. C is the option according to given options. Okay. We'll move on to second question. Clear for everyone? Alkalinity of water in equivalent per liter is given by HCO3 minus plus 2 into CO3 minus 2 plus OH minus minus H plus. All this is represented concentration in the units. Very important. I told you several times in the class also. This formula is considering units mole per liter. For a water sample, the concentrations of HCO3 minus 2 into 10 power minus 3 mole per liter, CO3 minus 2, 3.04 into 10 power minus 4 mole per liter, and pH of water is 9, atomic weights of calcium 40, carbon 12, oxygen 16, concentration of OH minus and H plus are neglected. What is the meaning of this? Even though pH is given, you neglect this pH not required, because from pH only you will get H plus concentration and OH minus concentration. But they given clearly concentration of OH minus and H plus are neglected. The alkalinity of water sample, which units? Alkalinity of water sample milligram per liter as CaCO3. Alkalinity of water in mg per liter as CaCO3, what we call it as total alkalinity. Alkalinity of water in milligram per liter as CaCO3, we express in the word total alkalinity. What is formula? HCO3 minus considered in milligram per liter into 50 by 61 plus CO3 minus 2. Again, CO3 minus 2 taken in mg per liter into 50 by 30 into 50 by 30. Is it clear? Now, what is given data? Bicarbonates HCO3 minus. Which units it was given? HCO3 minus is given mole per liter. HCO3 minus given in mole per liter, na? 2 into 10 power minus 3. 2 into 10 power minus 3 mole per liter. But do you need it in mole per liter or mg per liter? Tell me. You need in mg per liter, clearly written here. So now we are converting to mg per liter. 2 into 10 power minus 3 into HCO3 minus molecular weight, atomic weight 61 into 1000. So HCO3 minus hydrogen 1, carbon 12, 3 oxygens are there, 3 into 16, total 61. So that is atomic weight, 2 into 10 power minus 3 into 61 into 1000. So what is finally HCO3 minus concentration in mg per liter? This is in mg per liter now. This is in milligram per liter now. So what is in mg per liter now concentration? 2 into 10 power minus 3, 61 into 1000. 10 power minus 3000 is cancelled. 2 into 61. It will take directly na? 122 mg per liter. HCO3 minus in mg per liter. Now, What is given? Carbonate in mole per liter. Carbonate concentration is given. What is the value? We'll take carbonate 3.04 into 10 power minus 4. Which units it was given? Which units it was given? Mole per liter. So we'll take 3.04 into 10 power minus 4 mole per liter. Same formula will apply. Mole per liter concentration into atomic weight into 1000. 3.04 into 10 power minus 4 into atomic weight 60. Only additionally present is hydrogen only. Additionally present is hydrogen only. So we are removing 1. Total atomic weight 60 into 1000. Into 1000. Now what you are getting for carbonate in milligram per liter? Carbonate in milligram per liter. After calculation, how much you are getting? 18.24 milligram per liter. 18.24 milligram per liter. So this is bicarbonate HCO3 minus. This is carbonate CO3 minus 2. Now what we can write down? Total alkalinity. Our target is TA. Total alkalinity. Bicarbonate 122 into 50 by 61. Carbonate 18.24 into 50 by 30. This is the answer now. Total alkalinity 122 into 50 by 61 plus 18.24 into 50 by 30. That is, you are getting answer 130.4. What is the unit? Unit is milligram per liter as CaCO3. Unit is milligram per liter as CaCO3. Is it clear? What is the answer? Option A. Option A is then 130.4. Option A is the answer. So answer is A. Answer is A. We'll move on to next question. So again 2 marks question from set 2. See the importance of quality of water. This is a 2 marks question in set 2. This is also 2 marks question in set 2. Set 2 get 4 marks from quality of water in 2020 GATE. The ion product of water pKw is 14. Ion product of water pKw is 14. If a rainwater sample has a pH of 5.6, the concentration of OH minus in the sample not directly, 10 power minus 9 mole per liter in terms of 10 power minus 9. This is 10 power minus 9, you take like this, 10 power minus 9 mole per liter, rounded off to 1 decimal place. Okay, simple question, very simple question. pH is equal to 5.6. What you can write down for POH? 14 minus pH. POH 14 minus pH. 14 minus 5.6. So 14 minus 5.6 is equal to 8.4. 8.4. Now after this, directly we'll take now OH minus is equal to 10 power minus 8.4 mole per liter. No need of logarithmic calculation and all those things. You just take 10 power minus 8.4, that is directly OH minus in mole per liter. But what is the question is asking? In terms of 10 power minus 9. So you just take 10 power minus 8.4 in your calculator. Just press is equal to button. This is a shortcut. No need to do anything. No calculation required. Take 10 power minus 8.4 in your calc. Just press is equal to button. You will get one value. That is your answer. What you are getting? 3.98 into 10 power minus 9 mole per liter. So already they are asking to express in 10 power minus 9. So what is the answer now? What is the answer we can write down? 3.98. Because question is to express in terms of 10 power minus 9 mole per liter. Question is to express in terms of 10 power minus 9 mole per liter. So our answer is 3.98. 2 marks, very easy. Na? Just a simple conversion. pH is equal to 5.6. POH 14 minus 5.6. Then OH minus directly 10 power minus POH. Directly we have written. Answer we are getting 3.98 into 10 power minus 9. So we have to express in 10 power minus 9 mole per liter. So we are taking 3.98. Oh, very big question. We'll go ahead. This question is related to sedimentation topic. Set 1 2 marks question. Question related to sedimentation. Surface overflow rate of primary sedimentation tank 20,000 liter per day per meter square V naught. So you consider V naught. Surface overflow rate V naught 20,000 liter per day per meter square. So I am writing it in terms of meter cube per day per meter square. 20,000 liters is equal to 20 meter cube. Na? So 20 meter cube per day per meter square. We can take it easily 20 meter per day. 20 meter per day. V naught is equal to 20 meter per day. Kinematic viscosity of water 1.01 into 10 power minus 2 centimeter square per second. Which units we take always kinematic viscosity? Meter square per second. So I am converting centimeter square to meter square. 1.01 into 10 power minus 6 meter square per second. Remember, all units are converted. Meter per day, liter per meter square per day to meter per day, centimeter square per second to meter square per second. Specific gravity of settling particle is 2.64. Yes, no need of any conversion. Acceleration due to gravity, G, 9.81. The minimum diameter of particle, very important word you remember. Within brackets they give you always. We forgot about it. Micrometer, lowest diameter of particle in micrometer. That will be removed with 80% efficiency. That will be removed with 80% efficiency. We'll solve the question now. The minimum diameter of particle that should be removed with 80% efficiency in the tank is. So we have the formula related to efficiency. We'll take the formula. Efficiency is equal to Vs upon V naught into 100. Efficiency is equal to Vs upon V naught into 100. What is Vs? We have to determine now. Vs is equal to efficiency into V naught by 100. So we can write it down. Efficiency 80%, 80 by 100 into V naught 20. We have taken already 20. So what is the value? 16 meter per day. Vs is 16 meter per day. And we have the formula for settling velocity because we need particle diameter. So we are taking the formula for settling velocity. Vs is equal to GD square by 18 nu into S minus 1 according to Stokes velocity equation. We'll consider settling velocity formula according to Stokes velocity equation. GD square by 18 nu into S minus 1. But in this formula, velocity must be taken in meter per second. So that's why I am taking now 16 divided by 24 into 60 into 60. Converting this meter per day to second. Converting to second. So that you will get velocity in meter per second is equal to G 9.81. D we have to determine. That is what the parameter we need to estimate D. D square divided by 18 nu. This is new value. Already we converted units also. 1.01 into 10 power minus 6. 18 into 1.01 into 10 power minus 6. S value provided 2.64. 2.64 minus 1. Now you can solve for D. Then after solving. So you can solve for D. After solving, what you are getting D? D is equal to 1.446 into 10 power minus 5 meter. 1.446 into 10 power minus 5 meter. So how can you write down in microns now? 14.46 micrometer. This is your final answer. 14.46 micrometer. This is your final answer, 14.46 micrometer. Okay, is it clear? This is a numerical answer type, so that directly will give up to what decimal value they mentioned, 1 decimal value. So we'll take 14.4 as the answer. 1 decimal value they have given. So we'll take 14.4 as the answer. Clear? So next question. Next question related to again sedimentation. This one is set 1. This one is set 2. Very big question. Two identically sized primary sedimentation tanks receive water for type 1 settling. You underline this. The information is completely related to type 1 settling, means Stokes law valid. Whenever it was given type 1 settling, you remember that Stokes law is valid. Discrete particles in dilute suspension clearly mentioned. So it is about Stokes law valid condition. And also they given information laminar flow. So given complete data that this is 100% related to type 1 laminar flow, means Stokes law valid condition. The surface overflow rate maintained in the two tanks. Two tanks are there. Two ideally. Two is given in the beginning itself. Two given. The surface overflow rate maintained in the two tanks. 30 meter cube per meter square per day. 15 meter cube per meter square per day. The lowest diameter of particle which shall be settled completely under 30 and 15 designated as D30, D15. Means V0 for tank 1 is 30, V0 for tank 2 is 15. The diameter of particle which can be settled at that V0, D30 and D15. Ratio of D30 to D15. Ratio of D30 to D15. We'll solve it. V0 for first tank is 30. V0 for second tank is 15. The particles which are settling at this D30, D15. Particles are settling completely. Now we will consider Vs is equal to V0 because particles are completely. So if you apply Vs is equal to V0 and it was given type 1 settling, Stokes law valid condition, and also they mentioned laminar flow. Type 1 settling, laminar flow mentioned, and completely the particles diameter D30, D15 settled. So we'll consider Vs is equal to V0 and Stokes law valid. In such a case, Vs directly proportional to D square. According to Stokes law valid condition, Vs is directly proportional to D square. Means Vs1 by Vs2 is equal to D1 square by D2 square. What is the D1 by D2? D1 by D2 is equal to under the root of Vs1 by Vs2. What is D1 and what is D2? D1 is D30, D2 is D15. What is Vs1 and Vs2? Vs1 is 30, Vs2 is 15. So after solving, what you are getting the answer? What you are getting the answer after solving? Root 2. Under the root of 30 by 15 is root 2. Root 2 value we know it. 1.41. 1.41. This is the answer. That is the answer. Again, this is numerically question. Numerically type question. NAT. 1.41. You are giving the answer. Clear? We'll move on to next question. During chlorination process, aqueous chlorine reacts rapidly with water to form Cl minus, HOCl and H plus. So given the equation, chlorine reacted with water, resulting HOCl, Cl minus and H plus. The most active disinfectant in the chlorination process. So no need of that information also. The question directly given also. What is the most active out of all? In the disinfection process, two components, HOCl and OCl minus are the two components, in which HOCl is the highly active, most active disinfectant. Efficiency of HOCl is far greater than efficiency of remaining components. HOCl is your answer. If you take order of efficiency, HOCl is more greater in terms of efficiency with respect to OCl minus. HOCl is carrying more efficiency than OCl. So answer is HOCl. Oh, again big question. So set 1 2 marks. A water supply scheme transport 10 MLD, 10 million liters of water daily through a 450 mm diameter pipe for a distance of 2.5 kilometer. For a distance of 2.5 kilometer. A chlorine dose of 3.5 mg per liter is applied at the starting point. Consider this is the pipe. Consider this is the pipe of travel. Then through this 10 mld of water is moving. Chlorine dose provided is 3.5 mg per liter. Clear? Diameter is given 450 mm. Diameter is given 450 mm. Length of travel is provided 2.5 kilometer. This is information. That is information related to chlorination pipe. So 3.5 mg per liter of chlorine applied at the starting point of pipeline to attain certain level of disinfection at a downstream, some downstream end. It is decided to increase the flow rate from 10 to 13. Very important point. You are increasing water flowing through the pipe from 10 million liter to how much you are increasing? 13 million liter, 13 mld. Increasing from 10 mld to 13 mld. Assume exponent for concentration 0.86 N. With this increased flow, in order to attain same level of disinfection, you are increasing water quantity, but you don't want to reduce efficiency, same level of disinfection. Chlorine dose to be applied at the starting point. Chlorine dose to be applied at the starting point. So question is given very clearly. Increasing flow rate 10 mld to 13 mld. Will they provided information that the pipe diameter increase? No. Pipe diameter increase is not happened. Clear? Same diameter of pipe, you are sending water of 10, instead of 10, you are sending water of 13. So that area is constant, discharge increases. Got the point? Area constant, discharge increases. Velocity of flow increases. Because of increase of velocity, what decreases? Time of contact. So time of contact decreases. You understand the point? Again, I am writing for your easy understanding. Area of travel is constant. So as you increase the discharge, 10 to 13 mld, velocity increases. Means water is flowing at a faster rate. When water is flowing at a faster rate, contact time, interaction between chlorine and water, contact period decreases. So if contact period decreases, if you use same dosage, efficiency decreases. If contact period is the same, efficiency is same. Decreasing contact period, efficiency decreases. But you want to maintain same efficiency, you don't want to reduce efficiency. Because of that reason, chlorine dosage to be increased. Contact period and chlorine dosage inversely proportional to one another. C is inversely proportional to T. Chlorine dosage is inversely proportional to T. This is the information relation. Relation between C and T. C is inversely proportional to T. So we'll take the formula. What is the name of the formula? What is the name of the formula? Waterson law. Taking Waterson law. What do we take? C power n into T is equal to constant. C power n into T is equal to constant. Two conditions are there here. Condition for 10 mld, condition for 13 mld. So what I am writing? C1 to the power n into T1 is equal to C2 to the power n into T2. What is formula for time? Is there any information about time? We'll take general formula for time regularly. Regularly we are having one formula for time. What is that? For any environmental engineering question, if you need time, you remember volume by discharge, V by Q. For any environmental engineering question, most repeated, you remember any time for any question, you remember the time for any time, contact period, Detention period, retention period, you take time is equal to volume by discharge. Now we'll apply it. Now we'll apply it. C1 to the power n into volume by Q1 is equal to C2 to the power n into volume by Q2. Why I am not writing V1, V2? Because you are not changing area, you are not changing length. Volume is constant. So our final formula. How can we get final formula now? Final formula we can write down now. C1 to the power n by Q1 is equal to C2 to the power n by Q2. So you have all except C2. What is C1 provided? 3.5. C1 provided 3.5. N is given 0.86. Substitute in it. 3.5 to the power 0.86. Q1 10 mld. C2 to the power 0.86. Q2 13 mld. Now solve for C2. How much you will get? Simple. How much you will get? C2 is equal to 4.75 milligram per liter. 4.75 milligram. Increase in 3.5 to 4.75. What is option? Option D. 4.75. Got it? C1 to the power n by Q1 is equal to C2 to the power n by Q2. Solving, we are getting C2. Option. What option we are writing? Option D. We'll move on to next question. The relationship between oxygen consumption and equivalent biodegradable organic removal, BOD, in a closed container with respect to time is as shown. So in a closed container, simply they are taking a graph. Organic matter concentration versus time, L versus T. In BOD kinetics, every time we'll discuss about this graph and I will derive equation easily. Every time we'll discuss about it in BOD kinetics. Organic matter concentration versus time, L versus T. So organic matter value is getting fall down. BOD consumed, oxygen consumed is increase. So this is related to BOD. This is related to BOD. And this is related to organic matter concentration, L. Because it is a falling down exponentially organic matter, BOD oxygen consumption increases exponentially. Now, assume that the rate of oxygen consumption is directly proportional to amount of organic matter degradable. DLT by dt is equal to minus KLT. Simple equation only. We know it, first order rate kinetics. It follows first order rate kinetics. We have derived it also. LT is the oxygen equivalent of the organics remaining at time t. So after time t, what is remaining organic matter, LT? For example, you take at this point, after 10 days, what is remaining? That is L10. LT is taken as L10 after 10 days. Exactly at certain point of time. And K is the degradation rate constant. L0 is the oxygen equivalent of organic matter at time 0. In the above context, correct expression is. So we'll have the formula already. Simple formula. BODT or LT is equal to L0 into 1 minus e power minus KT. Everyone knows this formula under BOD kinetics. No need of any explanation for it. BOD remaining after T days. Organic matter remaining after T days. Initial organic matter L0 into 1 minus e power minus KT. This is correct. Okay, we'll go ahead. This is correct. Then what about second one? BOD at time t is equal to L0 minus LT. Is it L0 minus LT? No. This is BOD remaining. L0 minus LT is representing BOD remaining. This is not the answer. BOD 5 is equal to L5. No. Organic matter remaining is L5. BOD consumed is BOD 5. So again, this is also not possible. initial organic matter is equal to LT into e power minus KT. No. This LT into e power minus KT is equal to L0 minus LT. These both are same. LT into E, sorry, this is also L0 you require. Total formula is wrong. Total formula is wrong. L0 is equal to LT into e power minus KT, 100% wrong. Total formula is wrong. So what is final answer? Final answer is A. Final answer is A. Okay, we'll move on. Next question. A stream with a flow rate of 5 meter cube per second, having an ultimate BOD of 30 milligram per liter, a wastewater discharge of 0.2 meter cube per second, having 5-day BOD of 500 milligram per liter. So we have two values here. Q1 5, Q2 0.2. Ultimate BOD of Q1 YU1 30. A wastewater discharge of 0.2 having BOD 5 of 500. So it is BOD 5, it is not ultimate BOD. So Y5 of second stream. Y5 5-day BOD of second stream is 500. Joins the stream at a location and instantaneously gets mixed up completely. Cross-sectional area of stream 40 meter square, which remains constant, not changing. BOD exertion rate constant 0.3 per day, logarithm to the base E, K value. The BOD remaining at 3 km downstream. So YR, BOD remaining, YR. What is the formula? Ultimate BOD into e power minus KT. Simple. YR required, ultimate BOD into e power minus KT. But first we need ultimate BOD for the stream 2. Na? Because stream 2, 5-day BOD given, not ultimate BOD provided. That is confusion in the question. Remember carefully. For stream 2, I have rounded off here. This is 5-day BOD, not ultimate BOD. So ultimate BOD for stream 2. 5-day BOD by 1 minus e power minus KT. 5-day BOD, how much? 500. 500. 5-day BOD 500 divided by 1 minus e power minus 0.3 into 5. K is given na 0.3. K is provided, clearly provided, K value 0.3 per day. So we are estimating for ultimate BOD. Simple conversion of 5-day to ultimate. 500 by 1 minus e power minus 0.3 into 5. Ultimate value, how much you are getting? 643.66 mg per liter. Now, both mixed at one point. Na? Ultimate BOD mixed ultimate BOD. Formula, weighted average. Q1 Y1 plus Q2 Y2 by Q1 plus Q2. Weighted average. Here, Q1 Y1 plus Q2 Y2 by Q1 plus Q2. Q1 5, Q2 0.2. Y1 30, Y2 643. So Q1 5 into Y1 30 plus Q2 0.2 into Y2. This ultimate only na 643.66 by Q1 plus Q2 5 plus 0.2. What you are getting? Mix BOD, mix ultimate BOD. How much you are getting? Weighted average. Weighted average 53.6 milligram per liter. Weighted average 53.6 milligram per liter. Now what you need? Remaining, to estimate remaining, first time is important. Time is important. Again, time is equal to volume by discharge. I told you already. Volume, cross-sectional area of the river into downstream length by discharge. Cross-sectional area of the river, how much? 40 meter square. Downstream length 3 kilometer. So 40 meter square into 3 kilometer, 3000 meter. What is discharge? What is the discharge? Will you take 5? No. 5 plus 0.2. This is discharge. And we need discharge in meter cube per second, that is we need in days. So we are multiplying again 24 into 60 into 60 discharge in days. Meter cube per day. So how much you are getting time? Time you are getting 0.26 days. Time you are getting 0.26 days. Now remaining BOD after 3 km. YR after 3 km. Ultimate 53.6 into e power minus kt. K is 0.3, t is 0.26. Clear? Yu into e power minus kt. 53.6 into e power minus 0.23 into 0.26 kt. What is remaining now? What value you are getting? 49.57 milligram per liter. This is the answer. Remaining yet to consume after location, after 3 km location, 43.57. Finish. We'll move on. Again from stream flow. So from the disposal of effluents, see set 1 2 marks, set 1 2 marks. Only from disposal of effluent you have 4 marks in 2020 GATE. Remember the importance of topic. Only from disposal of effluents you have 4 marks from 2020 GATE. Set 1 only, set 1 only. So a river has a flow of 1000 mld. BOD 5 and DO values are 8 milligram per liter before receiving the wastewater discharge at location. Clear? We'll write down now. Q1 is equal to 1000 mld. BOD 5, Y5 for first stream, 5 mg per liter. DO1, 8 mg per liter. This is first information for river. So before receiving wastewater discharge, this is information. For the existing environmental condition, the saturation DO level is 10. DOS, saturated DO, 10 mg per liter. Saturated DO, 10 mg per liter. Wastewater discharge of 100 mld with BOD 5 of 200. So you write down Q2 100, Y5 2, 200, DO2, 2 milligram per liter. Clear? Wastewater discharge of 100 mld, BOD 200 milligram per liter, DO 2 milligram per liter. Falls at that location. Assume complete mixing of wastewater and river. Both mixed properly, completely mixed wastewater and river. What is required? Immediate DO deficit. Question is about DO deficit. Is there any use of BOD values in the question? Not required. Just to confuse you, they are giving BOD values. BOD unnecessary in the data. So we'll estimate through weighted average again, DO mix of solution. DO mix of solution. First 1000 mld with DO 8. Next 100 mld with DO 2. Divided by total discharge. Total discharge 1000 plus 100. DO mix. What you are getting for DO mix now? Weighted average DO mix you are getting 7.45 mg per liter. But question is about DO deficit. What is formula for DO deficit? Saturated DO minus available DO. Saturated DO minus actual. Actual is available. Actual DO. Saturated DO is given 10. Actually, according to mix phenomena, we got 7.45. So what is DO deficit? 2.55 mg per liter. DO deficit is considered as 2.55 mg per liter. So again, this is NEAT type of question. NEAT type of question we are having 2.55 mg per liter is the answer. Okay. We'll go ahead. This is the answer. Simple. Very simple. Just you are estimating DO mix and then calculating DO deficit, subtracting from saturated DO. Oh, air pollution. This is related to, no, it is related to THOD. Okay, THOD. It is related to THOD. The sample of water contain organic compound C6, C8, C8, H16, O8, C8H16O8, and its concentration is 10 power minus 3 mole per liter. Concentration of 10 power minus 3 mole per liter. Given atomic weights, carbon 12, hydrogen 1, oxygen 16. Theoretical oxygen demand of water in gram of oxygen per liter. THOD required. THOD required in gram per liter. In gram per liter. So THOD required in gram per liter means, first of all you have to convert given mole per liter to gram per liter. Given mole per liter to gram per liter, just multiply with the molecular weight. Simple. You got it? Just multiply with molecular weight. So what is molecular weight of this one? C8 means 8 into 12. Atomic weight of carbon 12, C8 plus H16. So 1 only, so we'll take 16 plus oxygen 8. 8 into 32. C8H16O8. What is atomic weight now? 240. 240 gram per mole. Atomic weight is 240 gram per mole. 240 gram per mole. So what you can take now? Converting C8H16O8 from mole per liter to gram per liter. Just multiply with atomic weight. This is atomic weight, molecular weight. Multiply with molecular weight. Molecular weight. Just multiply with molecular weight. Now 10 power minus 3 into 240. Simple, na? 10 power minus 3 mole per liter into 240 gram per mole. Mole and mole getting cancelled. So you are having gram per liter. 0.24 gram per liter. Gram per liter. Now, what is next? We have to convert to THOD. THOD formula. Given concentration of X into N into 32 by molecular weight of X. This is formula. Given concentration of X into N into 32 by molecular weight. What is N? Number of oxygen molecules required. Number of oxygen molecules required. So we'll take C8H16O8 combined with 8 molecules of oxygen. Combined with 8 molecules of oxygen releases 8 CO2 and 8 H2O. 8 CO2 and 8 H2O. Okay. So 8 molecules of oxygen needed for 1 molecule of this one. Then we'll substitute in THOD formula. We'll substitute in THOD formula. THOD is equal to X. X is 0.24 into how many molecules of oxygen? 8 molecules of oxygen, each with molecular weight 32, divided by what is molecular weight of chemical? 240. Molecular weight of chemical is 240. So finally, what is your answer? THOD 0.256, and this is taken in gram per liter. Na? So your answer is also gram per liter. This is the answer. 0.256 gram per liter. 2 marks question. Simple. Only thing you convert mole per liter to gram per liter. Understand how many oxygens are required for degradation. Just take into the formula 0.24 into 8 into 32 by 240, 0.256 gram per liter. Oh, think solid waste management question. A waste to energy plant burns a dry solid waste composition. Dry solid waste is burnt off composition. Carbon 35, oxygen 26, hydrogen 10, sulfur 6, nitrogen 3. Emits 20%. So first we write down this carbon, hydrogen, nitrogen, sulfur. Carbon 35, hydrogen 10, sulfur 6, nitrogen 3. So percentage we are writing P, percentage. Carbon 35, So we are writing the composition in the form of a table. Carbon 35, hydrogen 10, sulfur 6, hydrogen 10, sulfur 6, nitrogen 3%. Okay, done. We have written as a table. Burning rate is 10,000 tons per day. So every day 1000 tons is degraded. Every day 1000 tons degraded means, so what is the mass available for every 1000 tons degradation? For every 1000 tons degradation, what is mass available? 35% of 1000 tons, 350 tons, 10% of 1000 tons, 100 tons, 3% of 1000 tons, 30 tons, 6% of 1000 tons, 60 tons. This is mass in terms of ton per day. Individual masses. Total waste is 1000 tons per day. In that, carbon is 35%. Means 350 tons is carbon. Total waste is 1000 ton per day. In that, hydrogen is 10%. 100 is hydrogen. Like that, we are estimating the mass. Good. Assume complete conversion of carbon to carbon dioxide, hydrogen to water, sulfur to sulfur dioxide, nitrogen to NO2. So all are utilizing oxygen, all are taking oxygen and converted. Carbon to carbon dioxide, hydrogen to water, sulfur to sulfur dioxide, nitrogen to NO2. Atomic weights, hydrogen 1, carbon 12, nitrogen 14, oxygen 16, sulfur 32. The stoichiometric amount means theoretical amount of air. Theoretical amount of air in tons required to complete burning of waste. So carbon is converted to carbon dioxide. We'll write down here. Carbon is converted to carbon dioxide. C plus O2 gives CO2. Okay. So 1 molecule of carbon and 1 molecule of oxygen. 1 molecule of carbon atomic weight 12. 1 molecule of oxygen atomic weight 32. So that how much oxygen required for? 350 tons. Oxygen required for 350 tons. 32 by 12 into 350. Just cross multiplication. See here. Carbon is 350. How much is oxygen? What you will do? Simple cross multiplication only. Na? Same thing. Same thing will go ahead with water molecule. 2 hydrogen molecules with 1 oxygen resulted H2O. 4 parts of hydrogen, 1 part of oxygen combined. So atomic weight is 4 for hydrogen, 32 for oxygen. For 100 tons of hydrogen, how much oxygen required? You got the point? Hydrogen, 2 molecules of hydrogen react with 1 molecule of oxygen resulted 2H2O. In that, atomic weight is 4 for hydrogen, 32 for oxygen. Total hydrogen is 100 tons. What is hydrogen? What is oxygen? You can write it down. 32 by 4 into 100. Same we are applying for the remaining also. Same we are applying for remaining. How? N plus O2 gives NO2. S plus O2 gives SO2. We'll take like this. Then N. 14 is atomic weight. 32 by 14 into 100. Yes. 32 is atomic weight. 32 by 32 into 100. So what is oxygen required individually now we'll get? Oxygen for carbon dioxide, oxygen for water, oxygen for nitrogen dioxide, oxygen for sulfur dioxide. Calculate the values. For carbon dioxide 933.33, for water 800, for nitrogen dioxide 68.57, for sulfur dioxide 100. So I am writing here clearly for your easy understanding. Oxygen for carbon dioxide, oxygen for water, oxygen for nitrogen dioxide, oxygen for sulfur dioxide. Oxygen required. So total value. What is total value? Sum total. Total oxygen required. What is sum total of oxygen required? Tell me. Add all values. Add all values. 1861.9 ton per day. 1861.9 ton per day. And very important, already oxygen is available in the waste. No? We miss this. Already available oxygen in the waste 26%. So oxygen in the waste 26% of 1000 tons. 260 tons of oxygen already there. Already 260 tons of oxygen is there. Required is 1861. Available is 260. What is the net oxygen? We'll write here. Net oxygen 1861.9 total required, 1861.9 total required minus available. How much available? 260. 26% of 1000 tons. 260. So what is the net oxygen? Minus now, you can do minus now. 1601.9 ton per day. 1601.9 ton per day. Okay, good. Net oxygen 1601.9 ton per day. But will the air? Question is about air. Amount of air required. This is important. Question is about air. Amount of air required. Will air contain 100% oxygen? No. Air does not contain 100% oxygen. Amount of air contain. What is oxygen by weight? 23%. Oxygen by weight. Available oxygen by weight is 23%. Means if you give 100 kg air, that 100 kg air will give 23 kg oxygen only. So you will take 1601.9 by 0.23. This is your final answer. Don't go for that one. Air required, each one part of air will give 0.23 parts of oxygen. Each one part of air will give 0.23 part of oxygen. 1601.9 by 0.23. 6964.78. That means if you give 6964.78 tons of air, it will deliver you, it will give you 1601.9 ton per day. So this is your answer. Answer is 1664.78 ton per day air required. That is final answer. Very big question, very complicated, very confusing. So you make it in the form of a table. If you make it in the form of a table, question is easily completed for you. Okay? We'll move on. A gas contains two types of suspended particle having average sizes of 2 micron, 50 micron. Amongst the options given below, most suitable air pollution control strategy for removal of the particle. For 50 microns, always will go ahead with, tell me, gravity settling chamber. Equal to or greater than 50 microns will go for gravity settling chamber. 2 microns, two components are there. Electrostatic precipitator is there, fabric filter is there. So we'll check the options. Depending on option, we can take electrostatic precipitator followed by cyclonic separator. No. Actually, first cyclonic separation will be done, then electrostatic precipitation will be done. Second one. Electrostatic precipitator followed by Venturi scrubber. No, Venturi scrubber is not for considering for this. Discard it, reject it. Settling chamber, yes, this is gravity settling chamber. Followed by bag filter. Yes, correct. Perfectly suits it. What is D? Bag filter followed by electrostatic. No. We always go first electrostatic precipitation, then bag filter. And also 50 micron is there. Without settling chamber, we can't go for it. So answer is, you understand? 50 microns particle is separated by settling chamber, followed by bag filter. Order of treatment is very important. So we gone for it. A gaseous chemical has a concentration of 41.6 micromole per meter cube. Air pollution question. 41.6. Chemical name not given. Take it X. 41.6. 41.6. 41.6 micromole per meter cube. In air at 1 atmospheric pressure, 293 Kelvin. Universal gas constant 82.05 into 10 power minus 6. Okay, good. Assuming that ideal gas law is valid, N is equal to 1. Concentration of gaseous chemical in ppm, parts per million required. Concentration of gaseous chemical in parts per million required. Very good. So we have the formula X in parts per million is equal to, we have the formula X in parts per million. We need X in parts per million to be expressed. We have the formula X in microgram per meter cube is equal to X in parts per million into molecular weight of X into 1000 by volume in liter per mole. This is the formula. Okay. X in microgram per meter cube is equal to X in parts per million into molecular weight of X into 1000 by volume liter per mole. Volume from PV is equal to nRT. You take from PV is equal to nRT. What is volume now? nRT by P. N is equal to 1 you will consider. So now R 82.05 into 10 power minus 6. 293 Kelvin, pressure 1. So you will get the volume. Volume. How much volume you are getting? 0.024 meter cube per mole. 0.024 meter cube per mole. Okay, volume you obtained. X required. X value is given 41.6 micromole per meter cube. Now I am converting microgram. X converted to microgram. How? Multiply with molecular weight. X is equal to 41.6 into molecular weight of X, that is microgram per meter cube. When you multiply with molecular weight, micromole converted into microgram. So 41.6 into molecular weight of X. We'll equalize now. According to our first formula, we'll take this formula. X in microgram per meter cube, we use this formula. You can take this now. So 41.6 into molecular weight of X, which is in microgram per meter cube. That is equalized with X in ppm parts per million into molecular weight of X into 1000 volume. 0.024 meter cube per mole. We'll convert to liters. 24 liter per mole. We'll convert it to liters now. 24 liter per mole. So divided by 24. So mx and mx cancelled. Molecular weight of X cancelled. Now you derive X in parts per million. That X in parts per million you will get answer approximately nearly equal to 1 ppm. 1 ppm. Clear? So this is again NEAT type. So your answer is 1. Your answer is 1. So this hence these are the questions what we have done from GATE 2020 set 1 set 2 environmental engineering questions. I think you enjoyed a lot. Okay. If you have any query or anything related to question or inquiry or anything you want to know about your career guidance, what to prepare, how to prepare, or if you have any doubts in this video, you send a WhatsApp message to me, I will reply you. 89859 3112. Okay. Any doubts related to these questions or anything related to environmental engineering, no problem, you can WhatsApp me. I will be sending reply to you. I will clarify your doubts and anything your preparation, how to prepare and all those things also you can WhatsApp me. 89859 3112. So we'll be in contact again. 2019 video also I will release every year individually. Each year environmental engineering GATE solutions I will make it for you. Okay. Then if you are working for GATE and IS very hard, don't worry. We'll simplify in an academy. Our experienced faculty will simplify you. The top faculty have been joined Unacademy recently. So they are teaching you simplified subject for you. For example, myself, Krishna Prakash, I am having 16 years of teaching experience. I taught more than 150 batches for GATE and ESE. So I will give all shortcut methods to solve the questions for you. Simple, easy question, shortcut methods to you. In Unacademy, I am teaching Environmental Engineering 140 hours, Hydrology 60 hours, Irrigation 60 hours, OCF 30. Tell me in any coaching center this many number of hours they spend on the subject. No, this much depth, this much number of hours, no coaching center. Even you pay 60,000, 70,000, only half of the hours they will teach you. I am saying clearly, you pay 60,000, 70,000 also, only they will teach you half of the hours. Combinedly hydrology irrigation they will teach 60 hours. I am teaching here individually hydrology irrigation. Hydrology 60, irrigation 60. Just you are paying per year 25,000 rupees in Unacademy. Double the number of hours, double the subject, more in-depth subject you will get. So why to wait? Join now, enroll now. Use my code in the 25,000 also. Again you will get a discount using my code KP Civil. So I am teaching every day one special free class in Unacademy. Follow me in Unacademy by clicking on my profile KP Civil. You follow me every day, 1 hour free session I will teach. Every day daily through 365 days, 1 hour free class I will teach for you. Okay. Use my code if you want to take plus subscription. Use my code KP Civil. And one more surprise for you. Free online test series. In Unacademy app, I am providing you every week one test, Super 30 test series. Every week one test I will provide you. So you can write any student, free subscriber, plus subscriber, you are taking coaching center, coaching other coaching center, no problem. You can join, take free online test series, GATE and ESE. Weekly test, weekly one test, Super 30 test series. Okay? Then why to wait? Take enrollment in Unacademy. Let's crack GATE and ESE. Thank you one and all. Bye bye.